To begin, we can have a look at the range of stormwater controls in InfoDrainage, so from bioretention to ponds, swales, tanks, infiltration trench, and we have a drywell, or otherwise called a soakwell, in InfoDrainage. You can go to the help and explore more of the information that's provided there. To begin with, I'm going to demonstrate how we can create a dry well or design one in InfoDrainage. This is my model, which is a typical development area draining downstream to a pond. So one of the things we can do is import an object template. So these are useful for providing libraries of commonly used objects, elements like typical inflows with your land use and hydrology information set up, pits or inlets, and then you can see here we've got some common dry wells or soak wells with different shapes and infiltration capacities. What I have here is a catchment, and it's currently not draining to anywhere. Before I add a soak well, I'm going to run the deluge function, and this is going to give us an idea of where the natural surface is sloping towards, which might indicate an area where we can place a soak well on the property. So you can see here the flood extents here, showing depths from 10 mils up to a metre. So in this ponding location, we're going to place a soak well. We have those template soak wells I showed earlier. So to use them, we can just drag them on and place them in the area that we need them. And then we can make some changes from that point in time, and it'll have most of the information populated with that template. Otherwise, another way we can do it is just using the default method, and that's dragging on again, and this time placing two vertices and then dragging out the area. From there, we can go and open the properties and change the shape if we need to. It'll automatically set an exceedance elevation based on the ground model provided, but you can change this. We're going to try and go with a 2 metre deep soak well, and then we'll change that shape to circular here. And you can change the diameter from this window. Set a porosity value, so how much storage it can hold. And then you can add some infiltration rates for the base, and then add some facade infiltration as well. It's got a sizing calculator here, so we can design up to exceedance levels. And we're going to run the calculator using the simple water quality volume method, and we're just applying a depth of rainfall to the area. So the catchment will have a look at the type of volume we need to capture, and then it'll spit out a volume estimate for us here. So with that volume estimate, we can accept it, shown here, and you can see the existing one we currently have. And we just apply that, and it will reflect out in the plan view for us. And then we can add some outlets, whatever configuration might be connected to that soak well. There's also options for pollution removal too. So that's how you could design a soak well. And now we can run a couple scenarios with some soak wells put in place, looking after different lots. This is just sort of a concept look, but they're all feeding into this street drainage here. So we've got a scenario with no soak wells and a scenario with some soak wells here. Each of these have a few different configurations that are being applied. As you can see as I go through them, and we can have a look at some of the cross sections. And lastly, this third one. You can even set freeboard requirements to design up to for the soakwells. But now I'm going to run the simulations for some design storms. And first of all, we'll inspect the base, so the one without any soakwells. I'm just going to go to an extreme rainfall event to exaggerate the differences here. But we can have a look at the profile for the drainage going to the street. And it looks like, based on the hydraulic grade line, that there's flooding in a couple of places. So we can step through the simulation time steps. The indicators will show us red where there's flooding and yellow or orange where the freeboard, so it's about to flood, is being hit. So if I go to the soakwell scenario and look at that same profile, we can see here with the maximum HGL, it's not reaching any freeboard. So we're actually attenuating those flows with our soakwells in this design. And you can see here that level in the soakwell. It looks like it was hitting the freeboard, so maybe we can increase that volume if need be. Another thing we can do is create a comparison report in InfoDrainage. So we can choose which storms. In this case, we're looking at that outlet of that street drainage for both the base and the soakwell scenario. And we're just going to have a look at outflows, but you could turn on other different results to inspect. And you can see that the outflow, the peak has been decreased, and the amount of volume that's being discharged downstream is reduced as well. And you can see the differences in those graphs. If we wanted to do an overland flow analysis, we can run a 1D, 2D, and this will show us what happens. Let's say if up the top there, we've got a pond and it's spilling to the surface. This can induce flooding to the model, and we want to see if the soakwells are going to be able to capture some of that flow, or we can put them in place. In this case, one of the soakwells is actually surcharging to the surface and spilling back through some properties, and the flow path is going back to the pond and collecting in some of the soakwells in the downstream area. And so we can just stop and turn on the max flooding.